Good morning. This is Unit 2, Day 8. This is going to be our last day of this unit. We're going to solve inequalities with one variable. You will be able to solve inequalities involving polynomials and rational functions using both algebraic and graphical techniques. Let's explore some common connections between inequalities and positive and negative signs of the expression. So if our function is greater than 0, it's to find the values of x that make our function, our y values, positive. To solve our function for values, or to solve f of x is less than 0, is to find values of x that make our y values negative, right? Less than 0, negative, greater than 0, positive. We're going to use a sign chart. So we have this function, x plus 3 times x minus 4 squared. And you guys know that this multiplicity 2, since it's an even multiplicity, it bounces off the x-axis and it goes the same direction, or the opposite direction. So if it's positive, it's going to stay positive. If it's negative, it's going to stay negative at this point. Determine the real number values of x that cause our function to be 0. Well, there's going to be a 0 when x is negative 3, and when x is 4, it's going to hit the x-axis, so that's the 0 of the function. So we're going to use these numbers, and we're going to check if it's positive, if our function is positive or negative between these numbers. I'm going to start with negative 3. This is the smaller one. And then we're going to go to 4. This is the bigger one. And I'm going to try something like negative 4, because that's on the left-hand side of 3. When I plug this into here, a negative 4, this becomes a negative 4, but it's squared, so this is positive. A negative times a positive. A negative times a positive is a negative. So this is a negative. Alright, I'm going to try between negative 3 and 4. Like I said, I usually try to use 0. So 0 into here is a positive 3. Negative 4 squared is positive. So we have a positive. And it's going to bounce off at 4 since this is multiplicity 2, and it's probably still going to be positive. Let's make sure. Let's try 5. 5 plus 3 is positive 8 times 5 minus 4 is actually positive 1. And a positive times a positive is a positive. Perfect. So where is it positive? It's actually going to be not from 3 to infinity, because right here it's at 0. So 0 is not positive or negative. So what we will say is it's going to be positive negative 3 to 4 union 4 to infinity. Okay? It's negative over here. We're going to say negative infinity to negative 3. Okay? We cannot include negative 3. It's 0 at negative 3. Where a polynomial is 0, positive, or negative. Determine the real number values of x that cause your function to be 0. Okay, well this is just when the numerator equals 0. We don't really care about the denominator. Where the numerator equals 0 is when x is negative 3 and positive 5. Where is it positive? Undefined. Well, I'm going to have to use my sign chart for this one. I'm going to put negative 3 first, and then positive 5. And it's undefined when our denominator equals 0, so I'm going to set this equal to 0. So this is 2x minus 1 equals 0. Add the 1 to move it to the other side. We get 2x equals 1 divided by 2, x equals 1/2. This is when x equals 1/2. I'm just going to highlight it. You guys can rewrite it nicely. Alright, positive or negative, I'm not sure. I've got to actually test some of these points. I'm going to try negative 4. Let me just change the color, like negative 4. And I'm going to plug it into the whole polynomial. Negative 4 plus 3 is a negative number. Negative 4 minus 5 is a negative number. Negative times a negative is a positive. Negative 4 is negative 8 minus 1 is negative 9. So a positive over a negative is a negative number. So this is going to be negative. Negative 3 to 5, I'm going to try 0. Like I said, I like to plug in 0 if I can. Um, 0 is positive times a negative. Positive times a negative is a negative. 0 is negative. A negative over a negative is a positive. I know that's a lot, guys. Just try it out. Oh, but we have this undefined right here at 1/2. This means it's going to probably be a vertical asymptote. So I need to try something in between 1/2. So this will still work over here, it's still positive. But at 1/2, the asymptote could change on the other side of the asymptote. So I'm going to try something between 1/2 and 5. I'm going to try like a whole number, like 1. 1's easy. So I'm going to make this, what color? Red. I'm going to try 1. When I plug that into here, I get 3 negative, so positive, and then a negative, and then I get a positive. So this is actually going to be negative right here, negative. And then something on the right hand side of 5, I'm going to try 6, positive, positive, positive. So this is definitely positive. Alright, if you guys want to go ahead and graph it, there's an asymptote right here at 1/2. And this graph looks something like -3, 0, maybe like right here, -3, 0. It looks something like this. And 5, 0. Maybe something like this. Okay. Check it out. Make sure I'm right. But I know that it was negative until this point, -3, and then it became positive. And then after the asymptote, it was negative until 5, and then became positive. So something like this. Now I'm going to mark my domain for positive numbers. Positive numbers starting right here at -3, all the way up until my asymptote, which is 1/2, positive 1/2. And then union, there's another place where it's positive after this point right here is at 5, all the way to infinity. So 5 to infinity. Negative below the x-axis, or below the x-axis right here. So this is negative infinity all the way to this point, which is at -3. And there's another place, union, put the U. It is at, this is the asymptote, so it gets very close to 1/2 all the way until this point right here. So this will be 5. Alrighty guys, so this is the graph, and this is where our polynomial is 0, positive, negative, and undefined. Alright, so go ahead and flip your paper over. This is solving a polynomial inequality analytically. So remember, to find the zeros, it's p over q. P is the 6. So we do plus or minus 1 plus or minus the factors of 6. 1 and 6, right? And also 2 times 3. So 2 plus or minus 3. These are the factors of 6. The factors of the leading coefficient is 1. The factors is just plus or minus 1. And then we divide them, p over q. 1 over 1, 2 over 1, 3 over 1, 6 over 1. That's just the numerator. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We need to divide these before we can factor. I mean, if you can factor this and go ahead and try, but I will need to find the zeros first, or at least 1 0. What we can do easily is just plug in a number into this polynomial and see if we get 0. If we get 0, then it definitely is a 0 of this polynomial. So if I plug in 1, I get 1 minus 4 plus 1, and then plus 6. No, that's not a 0. Negative 1 minus 4 minus 1 plus 6. Sorry, this one was -1. Yeah, this one actually works. -1 would work. Also, I think -2 would work. Well, actually, +2 works if you plug it in here. So I'm going to try 2 first. You guys can try 1 would work. And we're going to put it in the box, put the coefficients. I have 1, -4, 1, and 6, and I do not have to skip anything or put a placeholder in there. I'm going to bring down the 1, multiply it by 2 is 2, Negative 4 plus 2 is negative 2, times 2 is negative 4, plus 1 is negative 3, times 2 is negative 6. Perfect, it worked. Alrighty, so I know x minus 2 is a factor because of this. Now I'm left with x squared minus 2x minus 3, which I can actually factor. And this is going to be x, and x gives us x squared. I know my factors are 3 and 1, but I know the bigger one has to be negative. So minus 3 plus 1. Ooh, negative 1 did work. Okay, so these are my factors, x minus 3 and x plus 1 is less than or equal to 0 because that's what we had. Alright, so now we're going to go on to the sign chart. We're going to use these points. This is when x equals positive 2, positive 3, and negative 1. So I'm going to start with negative 1, and then I'm going to go to 2, and then 3. Alright, on the left-hand side of 1, we'll try like negative 2. If we plug it in here, does it work? Is it less than or equal to 0? If we plug in a negative 2 into this, is it true? Is it less than or equal to 0? Negative 2 would work. This one would be true. Let's try like 0. When we plug 0 into here, we get 0 minus 0 plus 0, we get 6. Is this less than or equal to 0? Is 6 less than or equal to 0? No, this is false. Try negative 2. Alright, from 2 to 3, unfortunately, we actually have to try a decimal. I'm going to try 2.5 because it's an easy decimal. I'm just going to put this in my calculator, and I'm going to plug it in, substitute it in for every x value, and then add 6. This, actually, between 2 and 3 is true. Now, after 3, we're going to plug in like 4. Just try 4. And when I plug this in, I'm going to get false. So my solutions are where it's true. My solutions are going to be anything from negative infinity all the way to negative 1. And I can include negative 1. Union all the way from true is right here, so 2 to 3. That's it. That's it. Alrighty, let's go ahead and try this one, graphing it, solving it graphically. What we have to do first is get everything on one side of this equation. I really want my leading term to be positive, so I'm going to minus the 2 and then add the 8x. I'm just going to rewrite this nicely. It's going to be x cubed minus, just going to erase this. Trying to write neater. Okay, so we'll have x cubed minus 6x squared plus 8x minus 2, and then this is going to be less than or equal to 0. We only have to flip the inequality if we multiply or divide by a negative number, not adding and subtracting. Alright, so I need to first find my zeros to find out where I'm going to test. So I need to, since we can do this graphically, I'm going to graph it and then find out where my my zeros are, where it hits x-axis. So it looks like it hits right here, and right here, right? And it looks something like this. I don't know. Oops. No. Alright, so I see that it hits right here. If you hover over it on decimals, you'll see that it's like maybe 0.325. And then right here, it'll be like 1.46. And then right here, it'll be 4.214. Oops, that's a 1, okay? And now I'm going to plug in points. Actually, I know because of this graph that below or on the left hand side of point 3, it's negative. So it's negative. Between 3 and point 3 and 1, it is positive. Between this 1 and 4, it's below the x-axis, so it's negative. And on the right hand side of 4, it's going to go up infinitely, and it's on the right, it's on top of the x-axis, so it's positive. And we want to know where this function is less than or equal to 0. So where it's less than or equal to 0, or where it's negative. So right here, this is true. This is not true. This is true. That's it. So my solution's actually going to be negative infinity till this point at 0.325 union, and then right here to right here. So 1.46 to 4.214. And it includes these. These are okay. Alrighty. I'm going to highlight this for you. They want to know where it is below the x-axis. So right here it's below, and right here it is below. Okay. Alrighty. I want you guys to try the rest. If you have any questions, please ask me. Have a wonderful day.